So what we covered on Tuesday, we covered how to measure the masonry work. If you are constructing your building or your structure using bricks, whatever the type of these bricks, we need to handle how many unit you need to order, and also how much mortar you need to prepare to construct these bricks. We said that there is many types of bricks with different dimensions. So first of all, you have to figure out what is the type and what are the dimensions of your brick. As I mentioned before, the brick is defined by 3 dimensions. The first one is called the length of the brick. The second one is called the height of the brick. And the third one is the width of the brick. By the way, this width of the brick will define the thickness of your wall most of the time. The thickness of your wall. Otherwise, maybe we will build up 2 rows. If you have 2 rows of bricks, that means the thickness of the brick will be double this width. But in general, the width of the brick will define the thickness of the wall. Also, the area of the face of one brick will be defined by the length by the height. This is the length, this is the height. If you multiply these 2 dimensions, you can define the surface area of the one brick. This surface area will be used later. As I mentioned before, your brick wall can be solid without any opening. What you need only to multiply the length and the height of this wall. That's it. You can figure out the area of this wall. Sometimes the wall will contain opening. This opening can be door or can be windows. So if you measure the width of your window, door, it's typically 3 feet width and typically 8 feet height. This is the typical dimension of the door. Sometimes this information is not given, so you can assume logic dimensions. Also, for the window, the logic dimension may be 3 feet by 3 feet, maybe bigger or maybe smaller based on the size of your window. But we have 2 cases for the wall. Sometimes it's a solid without any opening, sometimes with opening, and this opening can be window or a door. Also, keep in your mind that we have different types based on material and different types based on dimensions of the bricks. My concern is right now the different dimensions. I don't care about the material so far because the material means different cost for the unit. We will cover this later after exam 1, but so far for the quantity takeoff, what are the dimensions? What are the dimensions of the brick? As I mentioned before, each brick will be defined by 3 dimensions. The first one is called the length, the second one is called the height, the third one is the width. We have 5 steps if you would like to figure out how many bricks in one wall. We need to follow up these 5 steps. The first step, I need to figure out what is the total surface area of your wall. What is the total surface area? Actually, what is the net total surface area of the wall? Why I said the net? Because sometimes we have opening and sometimes we don't. So your area surface equal the length of the wall by the height of the wall. If you have opening, you need to subtract this opening from the area. And keep in your mind, if you have many walls, we have a wall here, we have another wall, and we have another wall. and we have another wall to construct your room. So if you would like to figure out the total surface area of these walls, typically go ahead and find the perimeter. What is the length of this wall plus what is the length of this wall plus what is the length of this wall plus what is the length of this wall. So get the perimeter of these walls. Perimeter of all walls. Then go ahead and multiply this perimeter by the height of the wall or the height of the building or the height of one floor. The height, this is typically the height of floor, because the height of floor will give you the height of the wall. Typically, this height, most of the time, something about 10 feet. The typical height of your floor building, typically 10 feet, maybe more than 10, maybe less than 10, 9 or 11 or 12 sometimes. But typically, it's 10 feet. Once you multiply the perimeter for the whole walls or walls in your building, times the height of the floor, you can get the total surface area of the wall. You have to subtract from this total surface area, you have to subtract the openings. This opening can be in two forms, doors or windows. If you would like to figure out the total subtraction or the total surface area of doors that will be subtracted, it's very easy. Your door dimension typically 3 feet width by 8 feet height. And then you need to multiply this surface area 3 by 8 by the total number of doors. Everybody in this meeting can figure out how many doors in your house or how many doors in your apartment. It's very easy and you can find it from the drawing. So the total number of doors by the area of one door can give you the total area of doors. These are openings. Also for windows, you can figure out the total area for windows. One window typically is 3 feet by 3 feet if something else is given. And you need to multiply this surface area 3 by 3 by the total number of windows. Sometimes, most of the time, we have different sizes of windows. If this information is given, okay, go ahead and find out the area of each window if they are different. But if all of them the same size, for example, 3 by 3, or this information is missing, you can assume it. If you add this total opening by this total opening and subtract them from the total surface area, which is coming from the perimeter of the walls by the height, you can find out the first step, which is the total net surface area of the walls. I'm talking about many walls, not just one wall in your problem, but many walls in your apartment. This is the first step. We need to figure out the total net surface area of the wall equals the gross surface area, the total, minus the opening, okay? Second step, we need to figure out the surface area of one brick. One surface area. Keep in your mind, if you are given a brick, looks like this. This is the length and this is the height. I don't care about the width right now. Keep in your mind, I'm going to build a mortar on this brick, up and down, and from the side and from this side. This mortar has a thickness. Why I'm putting this mortar? Because I will build another brick up here and down here, and from this side and from this side. So if you would like to consider the surface area of one brick counting the part of mortar assigned to this brick, we need to increase the actual dimension of the brick by T. So this total dimension will be the actual dimension of the brick, L plus thickness of the mortar. We have thickness, half thickness from this side and half thickness from the other side. Also, the total height will be H plus T. So for example, if I'm giving you a brick with 8-inch, 3-inch, and 4-inch 3 dimensions, and I'm giving you a thickness for the mortar joint, this thickness equal 0.6 inch. So the surface area of your brick, area of one brick, will equal 8-inch plus 0.6 inch times 3-inch plus 0.6 inch. I will increase this length by this thickness because I have half thickness from one side and another half from the other side. So the total increase is 1 thickness. And also this height, 3-inch, will be increased also by thickness to give you what is the area for one brick. This is the second step. Calculate the surface area of one brick as position, including the mortar joint. We have mortar joint. Once you get the two areas in step number 1 and step number 2, I will divide step number 3. I will divide the area from step number 1 by the area of step number 2 to get the number of bricks. This number of bricks is not final. We need to adjust it if. Step number 4, this is if. Sometimes yes, sometimes no. Step number 4, if you are building your wall in 2 rows, we have here 2 rows of bricks. That means I have to multiply the number in step number 3 by 2. Sometimes, which is very rare, so I did not see this before, you can build up your wall and at 3 rows or 4 rows or 5 rows, I don't care. So in step number 4, I need to multiply the number of bricks from step number 3 by the number of rows, whatever the number of rows, 2 rows, 3 rows, 4 rows, I don't care. Also, step number 5, if you would like to consider extra number for waste, sometimes during construction we have broken bricks, we cannot use them, or for any reason we have waste, so we need to increase the ordered number a little bit, maybe 10%, 20%, 25%. It's up to you and based on your expectation about the waste. So the number you calculated from step number 3 must be multiplied by the total number of rows. Sometimes the total number of rows is 1, so keep it. And also we need to increase this number by a percentage, maybe 10%, 20%, whatever the percentage. So this will be the final number of bricks. This number must be integer, and sometimes we can round up this number to thousands of bricks. If you have a number, for example, 13,200 bricks, I will round up this number to 14,000 bricks. Sometimes. If your brick is ordered in unit price, I will order 1 brick equal $1. So I need to be careful about this number because the number will cost you more. And we did this example last meeting. The example is very, very easy. I'm giving you a wall with 8 feet height and 14 feet width, and we have opening like this door and this window. If the dimensions of these openings are not given, you can assume them, but the 2 openings, the dimension of these openings are given. So you can subtract the opening from the total surface area of the wall. Also, the mortar thickness is given, so I can adjust the dimension of 1 brick to figure out the area of 1 brick. Then I can divide the net surface area of the wall by the surface area of 1 brick to figure out the total number of rows. We have here the total number of bricks. We have here 2 rows, so I have to adjust this number by multiplying it by 2. And also we have extra 3%, so I have to multiply this number by 103, 1.03. I have another example here. I would like to share it with you. We have a room. This room is 35 feet by 25 feet in the plane. And the ceiling height, the height of this room, or the height of the floor of this room, equal 14 feet. As I mentioned before, if this information is not given, you can assume the height 10 feet. This is the typical height of your ceiling. But you have to follow what is given. We have opening for doors and windows. The total surface area. The total surface area. I think this number is too much. 85 square feet. But we can keep it. We can keep it. That's fine. Maybe most of the room is opening. That's fine. Find the number of standard size bricks. We have bricks 8-inch length, 4-inch height, 4-inch width. You should have delivered to your project to construct this room. And we are given the mortar joint equal 0.6 inch, and we have 1 row, and the extra waste is 5%. First of all, we have 5 steps. Step number 1, I need to figure out what is the area net of the walls. Keep in your mind, we have many walls because we are constructing a room. You have to understand your room looks like this. This is the typical shape of your room. Looks like this. And the given information, which is 35 by 25, 35 is the length of the room, 25 is the width of the room. And the height of these walls equal 14 feet. If you would like to figure out the total gross surface area of this room, I have to get the perimeter. The perimeter of this rectangle equal 35 plus 25 times 2. This is the perimeter, or the total perimeter of walls. I will multiply this perimeter by the total height of one wall, which is 14 feet. That means this is the total surface area of the walls. Since it's a problem giving me the total surface area of the opening 85, so I have to subtract 85 square feet from the total surface area of the wall. So we have a door here, we have window maybe, we have another door, we have another window, so the total surface area of this opening equal 85. So the total number, or the total net surface area of the walls, 35 plus 25 times 2, this is the perimeter, times 14, this is the total gross surface area, minus 85, I have total net area equal 1,595 square feet. Looks good. Looks good. Step number 2, I need to figure out what is the surface area of one brick. But you have to consider the joint thickness. The mortar joint thickness is 0.6. And your brick, one brick, looks like this. 8-inch, 4-inch, and 4-inch. So the surface area of one brick will be 8-inch. I have to add half thickness from this side and the half thickness from the other side. So I have to add the thickness 0.6. This is the length. The height, the same. I have to add half thickness from the top, half thickness from the bottom. So I will multiply 4-inch after adding 0.6. This is the thickness. This is the thickness. This is the length. This is the height of your brick. So the total surface area of one brick will be 8.6 times 4.6. I got 39.56 inch square. Be careful, because this area in square feet and this area in square inch, because the next step I will divide this area by this area. So step number number 3, the initial number of bricks will equal the total net surface area from the first step, which was 1595 square feet, divided by the surface area of one brick, 39.56. But this one in inches square. I cannot divide this one by this one. I have to convert one to the other one. I think I will divide this area by 144, or to be more specific, by 12 times 12. Or you can do it from the beginning. You can divide this one by 12. You can divide this one by 12 before multiplying both of them. It's up to you. But we have to convert this area from inch square to feet square. I have number, one divides the answer. I got here the number, that first initial number equal 5,805.9. So I will round up this number to be integer number, 5,806 bricks. Let me check with step number 4. How many rows will be constructed for this room? Actually, we are going to use one row only. So one row means this number will still the same, 5,806 bricks. Step number 5. Let me check. Are we going to consider waste? Yes, we are going to consider 5% waste. So the number will equal this number, 5,806, will be multiplied by 1.05, 5% extra. So we'll give you 6,096.3. You can round it to 6,100 bricks. So I need to order something around this number, or I need to estimate my cost for the material around 6,100 bricks. Later, maybe for each 1,000 bricks, the cost of this material will be $200, for example. Or later, for each 1 brick, the cost will be 25 cents each brick. Whatever the price of unit, I can convert this number to cost as cost estimator. That makes sense? But right now, we are focusing only on the quantity takeoff, how many bricks we need to order. Later, we will convert this number to a real cost. Anybody has any question about this example? Any question?
No, sir.
If you would like to figure out the quantity takeoff of mortar, I have 4 steps. The first step, I need to figure out this value, which represent how much mortar needed to construct 1 brick. How much volume of mortar needed to construct only 1 brick. This expression equal T, the thickness of your mortar joint, by W, the width of your brick. Your brick defined like this. This is the length, this is the height, this is the width. So this is the width, W. L is the total length of one brick. H plus H, the height of one brick, plus T, the thickness of the mortar joint. So this is the volume will be given in inch to power 3, inch cubic. Why? Because each dimension here will be in inch. So the value will be in inch cube. This is the total amount of mortar just only to construct one brick. Since from the previous example, you are aware how many bricks we need to construct, then I can multiply this amount of mortar needed for one brick by the total number of bricks. Then you can find out how much mortar needed to construct this number of bricks. That makes sense? Sometimes this one step number 3, if you are constructing 2 rows of bricks, if you construct 2 rows between this row and this row of bricks, we will fill the gap in between with mortar. So I need to increase the amount of mortar in step number 2 by something else. This number or this new amount of mortar equal this equation. The joint thickness by the total net surface area of the wall or the walls. They are many. Keep in your mind the thickness of the mortar is known and the total surface area of the wall should be known from the example, the previous example. That makes sense? This is the value, which is 1,595 square feet. If you multiply the thickness by this total surface area, you can get the additional. Mortar that will need it to fill the gap between the 2 rows. Also add this amount to the previous amount, then you can add extra percentage for any waste or any something like this. So let's do an example for this one, which you combine both of them. I need to construct brick walls 100 feet length and 10 feet high, and this wall will be constructed by bricks with these dimensions. This is the length. No, I'm sorry. This is the height. This is the width, and this is the length of the brick. We need to figure out how many blocks and how much mortar needed. Read your problem carefully. We need to determine the number of bricks and the quantity of mortar. Both of them in one example. Let's start with the number. If you would like to figure out the number of bricks, we have 5 steps, if you remember. Step number 1, what is the area net of the wall? This wall has 100 feet length by 10 feet high without opening. We don't have opening. No information is given about any opening in this wall. So the total surface area equals the total net area, 1,000 square feet. Step number 2. Since your brick is given like this, I do recommend to draw your brick to be more easy to understand. The length is given by 15 feet, inch and 5/8. And the height is given by 7 inch and 5/8. And the width is given by 7 inch and 5/8. So the area of one brick, I will consider the area of this surface. which equal 15 inch and 5/8 plus I have to consider the half thickness of the mortar from this side and this side. The thickness of the mortar equal 3/8 time the height after considering half thickness and the half thickness will be 7 and 5/8 plus the thickness 3/8. I think this one will give you 16 inch and this one will give you 8 inch. If you add the thickness of your mortar. So the surface area of one brick will be 16 times 8 equal 128 inch square. I can convert this number to feet square equal 0.89 feet square. I divided it by 12 by 12. If you would like to figure out the initial number of bricks, I can divide this area, which is 1,000 square feet, by this area, which is 0.89 square feet. So the total surface area will be, the total number of bricks will be 1,125 bricks. This is not the final number. I have to check how many rows do you have? We have 2 rows. We have 2 rows. So the final number or the total number, don't say final, total number will equal this number 1,125 must be multiplied by how many rows you have. We have 2. So time 2, I have 2,250 bricks. Since we have a percentage for waste, I have to consider, do you think we have waste? Is it given? Determine the number of browsers. We don't have waste. If you would like to assume it, that's fine. If you don't, no waste will be considered. I will count only. Final number will be 2,250 bricks. This is the first part of the problem. What is the number of blocks? If the waste percentage is not given, it's up to you as estimator. You can assume 5%, 10%, or you don't need to assume. It's up to you. Let's do the second part of the problem. What is the quantity required of mortar? We have 4 steps. Step number 1. What is the volume of mortar needed to construct one brick or one block? This one equal T, I think, time W, time H or L, I think, plus H plus T. I have to figure out the volume of mortar in inch cubed per one block by this expression. If I go back just to check, yes, T time W time L plus H plus T. So the thickness of the mortar is given by 3/8 inch. If you go back to the problem, the thickness of the mortar joint is given by 3/8 inch. And the width of your brick is given by 5 inch and 3 and 5/8. 5 inch and 5/8. Time, the length of the brick is given by 15/5/8. The H is given by 5/5/8 and the thickness is given by 3/8. To make life easy, I do prefer to convert this number to decimal. The life will be more easy. So 3 divide 8 is 0.375. This one I think will be 5.625. Yes, 0.625. This one will be 15.625. This one will be 5.625. This one will be 0.375. Then you can find the final number. So I can say, I'm sorry?
I think everywhere you got 5 and 5/8, it's supposed to be 7 and 5/8, isn't it?
I'm sorry, say it again.
Everywhere that you have the 5 and 5/8 marked, that should be 7 and 5/8. The width and the height is 7 and 5/8 of each brick.
Okay, okay. I got 5.625. I got here 45.6 cubic inch. This is the amount required from mortar to construct one brick. I do recommend to convert this number to cubic feet. So if you divide it by 12, by 12, by 12, because you are converting from inch to feet, but cubic inch to cubic feet. So I have 312. So this number divided by 12 by 12 by 12, I got 0.0264 cubic feet for each one brick. Step number 2, I can tell you what is the total amount of mortar needed to construct the total number of bricks. What was the total number of bricks? You have the final total number of bricks, 2,250. And what is the required amount for one brick? 0.0264. If you multiply this number by this number, I got 59.4 cubic feet mortar. But since we have 2 rows of construction of these bricks, I have to get the extra or the additional mortar to fill up the gap between the 2 rows. This extra will equal the thickness of the area net of the wall. Your thickness is 38.375 inch. By the surface area of the wall from the step number 1 or from the first part, the net area is 1,000 square feet. I cannot inch by square feet. I have to convert this one to feet. So 0.75 divided by 12 times 1,000 square feet. I got 31.25 square feet. And this one will be multiplied by T, which is, I'm sorry. So this is the total amount of additional mortar to be considered. We have extra? No, we don't have extra. So the total final volume of mortar will equal the amount needed here, 59.4, plus the extra amount needed here for the 2 rows. So the total will be 90.65 cubic feet. If this mortar, which is considered cement, sand, and water, if the ratio between the 3 amount of the 3 component or the 3 ingredient is given, I can convert this amount or this volume to different parts of cement, of sand, and water. But this is not a big deal right now. So far, I need to prepare or I need to order 90.65 cubic feet of mortar to construct this wall besides this number of bricks. So typically, I will ask you for one problem covering two parts. You have to tell me how many number of bricks and how much quantity of mortar needed to construct this number of bricks. As I mentioned the last meeting, the typical problem, but this will not be in your exam, but the typical problem to figure out how many bricks needed to construct this apartment, I need first to figure out what is the area net of the wall. If you would like to figure out the area net, so what is the perimeter by the height of the floor, then you have to multiply it or subtract the opening. Very easy. The first part, the perimeter, you have to add this length plus this length plus this length plus this length plus these lenses and this one and this one and this one and this one, this one, this one, this one, all of them. Don't consider any opening. Don't consider any opening. You have to consider all these lenses. Regardless, do you have a door or windows? I don't care. Do you know why I don't care? Because later you will subtract this opening. This is the perimeter. So you have to use your calculator to figure out the total lenses or the total perimeter of these walls. If you multiply this perimeter or this perimeter by the total height of the building or the floor, you can find out the total surface area. Then you need to subtract the opening. How to subtract the opening? You need to consider we have a door, we have another door, we have another door, we have another door. If you consider it with the perimeter of the walls, we have the main door for the building or the apartment. So you have to subtract the opening in terms of doors and windows. And keep in your mind, from this plan, looks like the windows are not the same size. If you look here, we have a size for the windows for this living room or this bedroom, and we have a different size for the window for this bathroom, and that makes sense. And also we have different sizes for the windows for the living room. So if you have different sizes, I'm sorry, you have to consider each alone and add them together. If all of them the same size, that's fine. And also we have opening here. This is a very big door. Looks like it's a sliding door. And we have a sliding door here also. I'm not sure if it's a sliding door or window. Whatever, it's opening. Does that make sense? Then once you get the area net, we no longer need this plan anymore. Just forget it. Because the next step related to the brick, the step number 3, you need to divide the first area by the second area. Step number 4, how many rows you will construct this apartment. And step number 5, what is the percentage of extra waste? That makes sense? So I'm gonna use this plan only for the first step to figure out what is the area net for the walls. Even for the mortar, if you would like to figure out the quantity of mortar, I will not use this plan anymore, because the first one related to how much per brick equal T times W times L plus H plus T. I don't need the plan. Step number 2, I have to multiply this amount by how many number of bricks. So I don't care about the plan. Step number 3, if you have 2 rows, I have to consider extra amount of mortar. So you have to use the total surface area from step number 1 or the first part. Then step number 4, if you have extra for waste. So the only use for this plan, only for the first step, how to figure out the total net surface area of your wall. You have to consider the total perimeter of this wall times the height of the apartment, and you need to subtract the total opening. Once you get this number, we are done with this plan. Any questions so far? Sometimes we have additional cost. Sometimes we have additional cost because looks like we have additional work can be constructed for the walls, like the bond beams. Sometimes we will, if the height of this wall is very high, we will construct at the top or maybe many times at mid-height something called bond beams. It's a reinforced concrete beams will be constructed from concrete and reinforcement. So if you have this case, we will have extra cost. And the volume of concrete needed for this beam looks like the same typical beam. We have a beam with width and thickness, and we can figure out the length of the beam to be constructed in this wall. Just to give you a hint, sometimes we have extra cost for extra construction. Sometimes if you have opening like door or window, keep in your mind how to construct the bricks over this opening. We need to put here a beam. In the masonry work is called lintel. Lintel is a beam placed across the opening like doors, windows, whatever, in building to support the load from the bricks above this opening. Does that make sense? Yes, we subtracted the opening from the number of bricks, but you have to consider over this opening, we must construct a special beam, which is called lintel. This lintel will have extra cost. That makes sense? And also the bond beam, as I mentioned, at the top of the wall, we to make sure the bricks are connected together and we have a very good connection. We can construct a beam, reinforced concrete beam at the top. So this one will have extra cost or separate cost. That makes sense? This is the last 2 points I would like to cover, but mainly in this module, we focused on how many bricks, how much mortar needed to construct your walls.